So I was happy to, let everybody else get in their seats. I was happy to find that there is a there there. So somewhere around 2000 and 2012, we saw a very significant drop-off in industry acquisition of infrastructure, servers, network storage. Well, why was this? Well, a lot of it was related to the fact that in the 10, 12, 13 years prior to that, we saw a tremendous amount of overbuying related to business-driven IT, the rise of new initiatives like the chief marketing officer, the chief data officer, and so on and so forth. And these folks created their own infrastructure. So around 2012, most organizations began to kind of look at all of this sprawl and said, wow, we gotta get our arms around this. This is getting ridiculous. And so they decided to embark on data center consolidation. It worked well in light of the fact that most CIOs were also thinking about a cloud strategy. So they really kind of stopped acquisitions for infrastructure about that period of time. And they did shift the focus to the cloud. In the meantime, we really began to kind of embrace this idea of the digital business and the implications of the digital business and what it means to actually implement a digital business in the context of deep analytics and insight. So really a lot of CIOs are really only now in the last couple of years understanding the implications of the cloud, understanding how to actually approach deep insight and analytics. And I think we're heading down a path of actually reinventing business through digital digitization. This isn't, there we go. The path that folks have been on, probably you have experienced, started with respect to the cloud, cost savings, consolidation, learning how to use automated infrastructure, this idea that I'm not so bought into of CapEx to OpEx, and then the innovation, understanding how to develop platform as a service-based applications, how to actually integrate APIs and the economy of APIs and apply analytics. And this is also where most of you began the process of understanding how to implement data lakes and use big data. The next stage is really where the business value comes in, and that is cognitive applications and advanced analytics and how to integrate all these pieces and parts to actually change the context of the mission of the business itself. So there's also this realization that it's not just a cloud world, it's certainly going to be a cloud world as we move to the future. Some organizations are going to move completely into the cloud. My thoughts are that just like the mainframe never went away, the hybrid environment is never going to go away either. So I like to think of this in terms of the multi-cloud universe or multi-cloud environment, where you're integrating some n number of private clouds with some n number of instances of applications that run in the public cloud, because you're going to embrace one vendor or provider's cloud for a set of business reasons, probably another for another set, and you're going to manage an ecosystem of providers based on the innovation that they bring. So, I mean, IBM certainly understands what it means to implement a hybrid cloud environment. We have our own terminology, this idea of private, dedicated, public. It doesn't really mean that you have to have this on-prem, but you certainly need to be able to embrace the capabilities for speed, flexibility, innovation, and insight, in so much as that you're enabling the implementation of big data, analytics, machine learning, cognitive capabilities. So IBM's approach has been an open, integrated framework that's focused on integrating all of these different tool chains together to facilitate a process of DevOps, both on the cognitive big data side as well as the operational side. Many of you see value in these open source tools, and they tend to actually come to market very quickly, and you want to integrate them in to some sort of framework that allows you to use the value of those open source innovative products and kind of chain them together. And you want to do so in a way that actually provides you with the capabilities for a powerful environment based on cognitive solutions. The important point here for us really is that it's open and that you're able to have choice with consistency and data and process platform portability. So if you do actually develop on the hybrid side or in a public dedicated instance, you can move that solution around in the cloud from one provider to the next, or from on-prem to in the cloud itself. So what are our customers really trying to do today? We looked at this with our last CXO survey. They're trying to create new multi-cloud applications. There's that multi-cloud universe again, so that economy of API-based solutions. They want to connect and unlock the power of that information that's in their existing legacy environments, and legacy can be something that you built yesterday, right? But they're trying to combine it with that customer experience side or that citizen experience side and other partners and ecosystems that kind of provides new insight and capabilities. And they also want to realize now that, especially through their exploration of big data and what it means to actually use some of these big data solutions, these unstructured databases that need synthesizing, and it tends to replicate themselves all over the enterprise, that they need to be able to optimize that process and make it a best fit. Because sometimes the first time you come up with a solution, it isn't always operationalized for efficiency. Some of the new roles that we're seeing as a result of this trend, and we're going to talk about the architectural patterns in a few seconds here, are business professionals that really understand how to act on insights to create new business models. We're seeing a whole range of new roles, and the cognitive business analyst is one of them. You've heard a lot about data scientists over the last few days. They have a set of different needs from those folks who are Java developers or Sling Hash in another way. And you see this new evolving role of data engineer, those folks who understand how to build effective data lakes, data ponds, and move the data around in the enterprise and within the cloud effectively so that you can manage these new applications. And of course, the application developers have to understand how to integrate these cognitive applications into the business process from a development point of view. Well, this is an interesting chart. You kind of read it from the outside in, from an onion kind of point of view. All of this phenomena that we just talked about is kind of giving rise to what we call the cognitive systems opportunity. So actually a system or capability called the cognitive system. And this cognitive system can exist in the cloud or on-prem, and begins with a set of activities that are layered on top of a data lake. If you really understand that pattern, we'll talk about it for a minute, that's a key transformational concept that's necessary to embrace advanced analytics and augmented AI methods, which feed into machine learning, which may be some of these prescriptive, predictive algorithms, neural networks, allow you to actually make observations about the potential outcomes. Well, those actually feed into this evolving science of deep learning. And deep learning really is all about taking massive amounts of data and layering all of these advanced analytics and machine learning concepts kind of together to train the system to train itself. So it's like the computer learning to learn. An example of that would be actually using the entire YouTube data set to basically train algorithms to recognize objects in videos. And I'm not talking about just faces, that's a face, that's a woman, that's a man. I'm talking about individuals. I'm also talking about all the way down to the cat running in back of the person, what kind of cat that is. And is it injured? Or what's its behavior like? Really, really interesting stuff. But this takes massive, massive amounts of data and a heck of a lot of processing. So you can't really do this on your stock x86 machine. Of course, all of these concepts certainly live in the context of the cloud and the cognitive API set, and you're not going to see these new AI systems actually evolve without any connectivity to the cloud environment itself. So you're going to have all of this grow up in conjunction with working on these solutions and interacting with them, things like Watson APIs in the cloud. Eventually, you're also going to see this concept be replicated into the cloud itself to ensure that you have choice with consistency. Well, clients kind of went through this journey. We touched on it a little bit. They get their feet wet with big data. They play around with unstructured data. They create dashboards. A lot of agencies really are still kind of to the right of this exploration, kind of creating dashboards and doing some, not really completely interesting big data analytics. But when they actually link it together and they begin to use it to train neural networks to do some predictive analytics, it becomes a little bit more interesting using frameworks like Redis and Cassandra. They really get serious about it. They change. The transformation is organizational in nature. They adopt some of those roles that we talked about, and they begin to integrate it into the business and planning itself. It's at this point that they kind of feel that customers really kind of experience the growing pains in these areas. The data sets are huge. The processing requirements are very large. They need something different. They need additional infrastructure in order to embrace these machine learning and deep learning and cognitive projects. So I don't know if you've heard this term before, but we're beginning to actually recognize this idea of the modern data platform. And here is a conceptual diagram of the process of the modern data platform and the core elements. So you have an ingest phase where you have to have adapters and a process for pulling in information, obviously, from different sources. And there's a persistence phase that includes data lakes and data management streaming. So real-time analytics are included. Then there's a process of analyzing and acting. And in reality, this persist and analyze and act kind of go back and forth many, many times. And that requires, again, different infrastructure, different approach, different tools, different processes. Eventually, you apply some sort of think and automate capability, some machine learning, deep learning algorithms to actually integrate into the business processes to create cognitive workloads. Well, let's talk a little bit about that data lake pattern. This is an excerpt from our analytics patterns. Really good stuff. If you get the opportunity to go on to DeveloperWorks and look at it, you can actually download this and use it yourself. This is the reference pattern for data lakes. What I really want you to come away with here is three things. That this is multi-staged process of data transformation. That it occurs in multiple stages and in different processes, but almost often goes between ingestion, transformation, analyzing it, and back and forth in multiple different cycles. And in many cases, it's constant and continuous. This means that you really need the infrastructure to be able to manage that, the tools and the role. And it almost always integrates some sort of hybrid solution. So it's multi-cloud with many different tools that support each of these different phases. And each of these different phases are often supported by open source libraries and data tool chains. So let's drill down a little bit further on that. Here you can see that we're ingesting, different types of data. You have your traditional data sets, you have your unstructured data sets. And in the persistence phases, you can see now that we're beginning to use a very different set of tools than we're traditionally focused on. And these are all open source tools that have some sort of distributor that's associated with them. Hortonworks, IBM's own Big Insights, Spark, Hadoop. And in the Analyze and Act, then you actually are using these neural networking, analytics, deep insights environments like EDP, Enterprise Database, and PostgreSQL for discovery, exploration, sensor respond, and business intelligence and reporting. Anyway, my point here really is that this is a lot of different tools chained together that are open source based, that are often not optimized to be able to run and respond effectively for customers. It works, but it's a lot of work to actually optimize it and tune it. So here's a couple of areas where we've gotten a little bit of experience, and then I'll actually build on this. MongoDB and EDB Progress, which is Postgres, which is what I was trying to say earlier, but I was a little confused by the chart, are two areas where we've actually applied IBM Power Systems to speed up and optimize these solutions. For MongoDB, we've actually gotten a 2 times price performance advantage against x86 servers, and almost a 1.8 for the EDB product, which is pretty good. So that's just a starting point. We're seeing these patterns that I talked about before play out over and over again with our customers. Here's a good reference. Florida Blue, which is Medicare and Medicaid in Florida, is actually using this process to ingest information from different providers, kind of constitute it into one data lake, analyze and act on it so they can actually have a conversation with their customers in real time. They've really reduced their processing time by 3 minutes or more. Their interaction time by 3 minutes or more. And they found that it was actually 3 times better from a cost benefit ratio than our closest competitor. Another example that we've seen over and over again, but the financial institutions, they do not want to tell you who they are that are actually doing this. This is fraud, waste, and abuse using graph-based sense and respond architectures. So you see that there's a data lake, there's traditional relational database sources coming together in the data lake. There's integration here with Watson APIs, and there's also some graph-based visualization and assessment using Neo4j. So again, chaining these tools together to actually provide a fraud, waste, and abuse solution. Well, we began to recognize that customers were having a problem in this space, and they were having issues with server sprawl. They were having issues with processing speed and throughput, and we decided to come up with a new form factor called the PowerAI, with a focus on accelerating deep learning and machine learning and analytics. It's a prepackaged set of deep learning frameworks It comes with an automation framework which allows you to deploy the software, and it's optimized performance because we partner with NVIDIA to actually deploy this with NVLink and GPUs. So it's really a supercomputer in a box focused on supporting AI machine learning. So if we get down into this, kind of like a motorhead chart, it's not every day I get to speak in terms of speeds and feeds anymore, being a software guy, but here's a few examples of the horsepower under the hood. High performance cores, basically twice the performance of our closest competitors. Very fast and large memory access through the bus, and fast acceleration and interconnects through NVLink. This is important because in order to actually support these new cognitive models, data lakes all the way through machine learning and deep learning, you're going to be using and employing parallel processing. Without parallel processing, you just won't have the horses to be able to respond. And quite frankly, it's, when we're talking about these new modalities of interaction, you've gone out and played with my robot, you notice they're having a little network connectivity issue. It becomes really annoying when you're actually talking to a cognitive application and it's not quite responding to you in conversational real time. That's really what we're talking about, is that artificial intelligence applications, machine learning, deep learning, require the speed to be able to make that new modality of interaction worthwhile for humans. Because as Rob said, this is about making you, the human, on the other end of the phone, working with the citizen, probably more effective. So about 5 times the processing power through these interconnect solutions using CAPI, which we're sponsoring the OpenCAPI consortia, which is the new bus architecture, and that'll be part of Power 9 here when that does come out. And we're working with the Open Power consortia to support this. So this is a group of industry partners. Some of them are competitors, Google, for example, who we partner with and compete against in some ways, developing these solutions together with IBM. So one thing to realize is this is not just about hardware. This is about a fit-for-purpose system. This is about co-optimized hardware and software working together that's fit for purpose, that has libraries that are built all the way down at the metal and into these open source frameworks to optimize machine learning, deep learning, and AI. And it's really important for us that you realize this is an open ecosystem of both hardware and software development where we're partnering with different constituents in the industry, the open source providers that are part of the tool chain, as well as these open libraries and, for example, Tensor and others to be able to deploy the solutions on an IBM form factor. So as I mentioned, it's all about partners, so that we got the Open Power Consortia, OpenCAPI for managing these new bus architectures and being able to support parallelism, open source workloads, taking all these tools, being able to chain them together effectively through a framework. You pick what you want to use, you mix and match. We'll support that. We're not trying to lock you into one software brand or another. And along with supporting the open frameworks and open libraries underneath of these open source tools that are important for building machine learning and deep learning applications like TensorFlow and Caffe and Theano and Chainer. So if this is an incredible system which combines these deep learning frameworks into now an automated, distributed, optimized set of deployment patterns. and this was actually just recently announced in the last week. Those distributed pattern frameworks, along with support for neural networks that are chainer related, which is another open source set of libraries. This is literally an AI cloud in a box. You can use it for anything, but certainly this is our concept. And this allows you to basically link an unlimited number of GPUs, NVIDIA GPUs via an NVLink to support processing requirements. It also integrates with a high-performance file system, and it scales to the cloud. So again, for you motorheads, hey, there's a tremendous amount of bandwidth between these GPUs and the CPUs and the system memory now, because these analytic workloads, these machine learning environments really take a lot more processing to be able to support. Here is the recommended configuration for the S822LC. Boy, that just rolls off the tongue. That is the name of the PowerAI system ID. You can throw up to 1 terabyte of system storage on that. That's pretty incredible. This is an example of the framework for the finance community. So we're actually working to actually focus on fit-for-purpose industry stacks. And we're doing, I think, a phenomenal job of integrating all of these pieces and parts together to influence these industry solutions to enable them for business use. Another area that is really important is this idea of object storage. If you think about object storage, I mean, what is the one file type where the majority of tacit knowledge is kind of locked into in an enterprise? Do you know the answer to that? It's PDF. All right, you got to be able to manage and get to PDF information and unlock that. That is a major goal of IBM. And you got to be able to manage all sorts of data types across those different cloud types, whether you're using IBM's cloud or Azure or AWS or on-prem, you have to manage that file system as one whole. CleverSafe allows you to do that and has been the market leader for the last 4 years. Another area that I think is really interesting, you can go out there and talk to the guys on the enterprise server, PED. This is just amazing how this team has turned the enterprise platform into an open source ecosystem environment with all of our partners. If you know anything about Spark, Spark is the industry-leading analytics environment that allows you to develop, used by data engineers and data scientists to basically come up with new algorithms and apply new capabilities. It's very much an in-memory resonant application, so it's a bit of a power hog and works best with an environment that actually supports massive memory management. So for, across all the different versions of Z systems and Linux One, you want to consolidate all those Linux servers. There's the box for you. I know you may not move to this box just simply because I'm talking about it, but the fact of the matter is that data consolidation and the use of this box now actually supports all of this deep insight capability. In general, I think that we're very well positioned from a systems infrastructure point of view to support AI and cognitive, all the different data access connections with our ability to connect to Watson on the cloud, both hybrid and public. And we have these integrated solutions that are part of our industry and domain implementations and specializations as well. Well, look, I think that you will find PowerAI and the other pieces of infrastructure that enable these cognitive applications to be pretty compelling. They really are infrastructure that really matters. 3 to 5 times the price point of our nearest competitor. Truly open infrastructure, open from not only a standards point of view, but open from an open source point of view, open from an open industry and open technology point of view, based on PowerAI to enable this next generations of deep learning by IBM, the cognitive expert. After all, we created this concept of the cognitive business. And so I think I'm about out of time. I really appreciate you listening. I'll take a question. So, if anybody has any. We are going to play a video after this. This is a video customer testimonial on this particular set of solutions around PowerAI and Open Power by Oak Ridge National Laboratories. Quite a compelling customer testimonial. And they're going to be announcing their solution here with the next supercomputer that's based on this architecture here over the next couple of quarters, I believe. So if you want to roll that, we can go ahead and go right into that. Thank you very much.